MS Ramaya University of Applied Sciences.
Hello friends, with this experiment we are determining the flakiness and elongation indices of a given aggregate sample. Apparatus: standard thickness gauge, IS sieve of sizes 63 mm, 50 mm, 40 mm, 31.5 mm, 25 mm, 20 mm, 16 mm, 12.5 mm, 10 mm and 6.3 mm and weighing balance. Particle shape and surface texture influence the properties of freshly mixed concrete more than the properties of hardened concrete. Rough textured, angular and elongated particles require more water to produce workable concrete than smooth, rounded, compact aggregate. Consequently, the cement content must also be increased to maintain the water-cement ratio. Generally, flat and elongated particles are avoided or are limited to about 15% by weight of the total aggregate. Procedure: Flakiness index. Take some aggregates and sieve them properly through the sieve set 63 mm to 6.3 mm in descending order. The taken quantity must be sufficient to provide minimum 200 sieved pieces for test. Separate the aggregates by their sizes and find the weight of aggregate of each size. Try to pass each aggregate through corresponding slot in the thickness gauge. Weigh all the pieces which passes through the particular slot. Elongation index. Sieve the aggregates through the sieve set and determine the weight of aggregates of each size separately. Try to pass each piece through corresponding gauge size. Weigh all the material retained by length gauge. Calculations and observations. Flakiness index. Total weight of material passing through thickness gauge, flakiness index in percentage are calculated. Elongation index, total weight of material W, weight of the material retained by length gauge, and elongation index in percentage are calculated. Data collection and tabulation is as shown in the table. Data collection and tabulation for elongation index is as shown in the table.
Hi students, as a part of Concrete and Highway Laboratory, now we are doing an experiment on flakiness as well as elongation index of the aggregate. So you know the different shapes of the aggregates. You are going to classify the shapes of aggregates into four forms. One we call it as a rounded aggregates. Second one we call it as a cubical or angular aggregates. The third one we call it as a flaky aggregate, and the fourth one we call it as a elongated aggregate. What do you mean by rounded aggregate? What happens? Aggregate, if you just simply observe, the complete spherical area appears to be rounded. So this is what we call it as a rounded aggregate. What happens in a rounded aggregate? You are going to get a good workability. The workability will be more. Whereas when it comes to the strength of this rounded aggregate, as there is no interlocking properties, the strength will be going to have a little variation. The second type of aggregate, what we call it as a cubical aggregate. So what is this cubical aggregate? It's having the corners, the cubical corners. So it also gives you the good workability as well as it gives you the good strength because of the interlocking properties. The next two things that what we are talking today is the elongated aggregate as well as the flaky aggregate. If you observe these two, what is this elongated aggregate? The length of the aggregate is more than the other dimensions. We call it as a elongated aggregate. Other word, on a flakiness, what is this flakiness? The surface area will be more and the thickness of the specimen will be less. This is what we call it as a flaky aggregate. So let us start doing the experiment. Before doing the experiment, let us go on with the apparatus required. The apparatus which is required now are we want the standard IS sieves ranging from 63 mm till 6.3 mm. What we are going to do is, we are going to collect 200 sample of pieces in each of this category. Like 63 to 50, I am going to collect 200 pieces. 50 to 40, I am going to collect 200 pieces. Next 12.5 till 12.5 to 6.3, I am going to collect 200 pieces of aggregates. Okay, so after collecting it, what I am going to do, I am supposed to get it tested. So I require a thickness gauge. This is what we call it as a thickness gauge, which is used to do the flakiness index test. This is what we call it as a length gauge. This is length gauge, which is used to perform the elongation index of aggregates. Also, we require a weigh balance to measure the samples. Now let's start the experiment. I collected 25 number of pieces of aggregate which is passing 25 mm and retained on 20 mm. What I am going to do is, I am going to weigh the total weight of sample which is collected, 25 pieces. So what I did, I weighed the 25 sample pieces. Why I taken 25 instead of 200 is just for the laboratory sake. Actually, as per standards, we need to do it for 200 samples. Note down this weight, the weight of aggregates which is passing 25 pieces, which is passing 25 mm and retained on 20 mm. I am going to keep it on one side. What I am going to do it is, I take one aggregate at a time. I am going to take this thickness gauge. I try to pass the aggregate in that concerned pattern, 25 to 20 mm slot on the thickness side. What happens? Some aggregates passes, some aggregate doesn't passes. Keep one side whichever the aggregates which is passing that particular thing. So this is not passing. So this one is passed. What I am going to do, I am keep it aside this particular specimen. So whichever is going to pass, I am going to keep it on one side. Whichever which is not going to pass, I am going to keep it on the other side. After segregating, what I am going to do is, I am going to take the weight of aggregate which is not passing the thickness gauge. I will note down the weight of aggregate which is not passing the thickness gauge. The ratio of weight of aggregate which is not passing the thickness gauge to the weight of aggregate taken gives you the flakiness index for that particular set of sieve. After doing the flakiness index test, the same 25 samples of aggregate, we are going to pass that in the length gauge along the length axis like this. So it's passing, this is also passing, this is also passing, also passing, this is also passing. I'll just segregate the aggregates which is passing and not passing. Almost all the aggregates are passing. So what I am going to do, I am going to take up the weight of aggregate which is passing that particular set of system. The ratio of weight of aggregate passing the length gauge to the weight of aggregate taken gives you the elongation index. This completes the tests on aggregates, particularly for elongation as well as the flakiness properties.
At MSR UAS, we spark your imagination unlike any other.